Okay, this is number crunching. One of the things that someone mentioned is that this seems similar to some things they might have done in biostats. This comes from statistics. And they're usually separate classes. I'm waiting for someone to come by and say, yeah, you're not supposed to teach any statistics. But there's no way today that you can separate statistics or data analysis from math because everything's data. If you just go look on Monster for jobs in math, it's all data stuff. So we're going to get to calculus and marry it to this. So we use both. Okay, numbers look okay. If your numbers don't look okay, you have me in here today. I'm going to let you go a little early. Ask me why they're wrong so that we can figure it out. That's what we need to do. As soon as you see a problem, stop it up and figure it out. We had Yuri come here. He's a Montclair State grad who had a 4.0 from his undergrad, and he went to UMDNJ, and he just got his MD PhD a couple days ago. I saw, and he came back and gave a talk to my pre-calc class last year, and he said that was his one thing that he did. He did the homework right away, and as soon as he had a problem, he addressed it right away. He went and found why it was wrong. If they didn't assign homework, he did homework anyways, just to make sure he understood everything. So he was dedicated and kind of got those out. He had fun. He said it didn't stop him having fun. He just made sure they were done first, and then he went and had fun. So you guys are probably not having much fun. Not any room for it. But if you did anything that I did, if I had a choice, unfortunately, I put the books away and I went out. So it's 19. That's what you do when you're 19. You don't make the best choices. I think down, God, what would have happened if I studied? I would be really great if I studied. Okay, so I showed you the next step. The next step is to build what's called the ROC curve or the ROC curve, receiver operating characteristic. And I asked you to copy and paste data or have one minus specificity on one axis, the x, and then sensitivity on the other. Somebody was asking why they do this. It's so that you can see positive against positive. So you're seeing the rate of the grades at each cut point against each other. So you want to actually maximize that curve from being 100%, right? You would like them to be as large as possible. And that's why you graph these two against each other. And I didn't think of that, actually. A student thought of that you want to see, these are the grades, actually. I could look over here and tell you right away where the best grade is. Looks like it's around here. High sensitivity and high specificity, right around 28 is the BMI, so I can see it from right there. So I don't need to see this, but that's because I went into the weird field of math. But people like to see the data plotted like so they can see the rate of the grades against each other. And where would be the optimal point on this? Right there, you want to minimize, you want to find the point which minimizes that distance. And you can kind of eyeball and see where that is. That happens around a little bit after 0.2 on 1 minus specificity. 0, 1. The coordinates of that point in the corner are 0, 1. So if you think of it as a drawstring, if you pulled it all the way back, you have a perfect diagnostic test because you're always right at the cut points for, you're always right on the specificity and you're always right on the sensitivity. So if it was fully pulled back, this curve, you took that, think of that as a string, and you fully pulled it back to that corner, you have a perfect diagnostic test, which is never going to happen. It's not going to happen. But this is not perfect, but it's incredibly smooth looking. In fact, I looked at that and I thought, I was plotting this with polynomials. I think it looks like a log to me more than a polynomial. So it actually makes the math easier. You think it wouldn't? The polynomials were pretty messy. So just from my eyeball, I thought it was around 28. Because 28 is 1 minus specificity is around a little bit bigger than 0.2. That's the x value that I looked at, and then I go back, calculate to where the BMI was that was attached to that specificity. It's 28. So my guess was kind of close to the guess that we had initially when we looked at the table. It's around 28. So those are eyeball tests. But in medicine, you have to be right? You want to tell people if it's cancer or not cancer. I feel at least if it's my models, I better be right. I want to be as right as I possibly can. And so we're going to use calculus. So I'm going to stop this module and actually go forward with this